So welcome everybody. Good afternoon, good evening, good morning to everybody. I'm Daniela, a researcher at GFZ Helmholtz Center for Geosciences and one of the coordinators of the research and development component of the Global Forest Observations Initiative. Today, we are very excited to discuss one of the GFOI R&D priorities, which is a monitoring of tropical peatlands and mangroves with you. Before we start, we have a few housekeeping items. The first one is that this meeting and this exchange will be recorded and it will be made available alongside presentations and other materials online in the coming days. The agenda we will introduce later, and it will consist in 4 short presentations followed by sometimes for clarifying questions, meaning short questions and short answers. After the 4 presentations, there is going to be a dedicated time for discussion and to engage in a lively exchange. In the meantime, we encourage you to leave your questions in the Q&A box as opposed to the chat option, as the Q&A box is a little bit more easy for us to monitor the questions that come and also which can be answered. The presenters themselves will also be monitoring this Q&A box and they can answer the questions as we move through the exchange. But of course, we will leave some questions for the dedicated discussion time after the presentations. We are hoping that you can all join actively into the discussion, and if you want to speak, we will be able to unmute you from our end. If you want to do that during the discussion session, just feel free to let us know by raising your hand. We have a great agenda ahead, but before we start, I would like to know, and we would actually like to know who is in the room by asking 2 questions. Let's see if, yes. If you can see in the screens, the first question that we would like to know is what type of organization is represented in this room with us. To answer this question, you can go to slido.com and enter the number that is in your screens, or you can also use your phones and read the QR code. It would be great to see, we are very interested to see who is represented in the room. See that there's a few people already answering from international organizations and of course from government bodies, as well as there's quite a strong percentage right now answering from academic or a research organization. It's great to see the overall broadness of who is joining this webinar. We were also able to look into your responses in the registration page. We would really like to thank you for also those that provided some insights into what were the key topics that you would want to hear during this event. So I see that there's quite a strong participation from research, but also from international organizations and governments as well. I will keep this question open in the meantime, but I would also like to move on to the second question, which relates to the topic of today, which basically includes our relationship with tropical peatlands and mangroves within our work activities. The second question relates to our relationship with tropical peatlands and mangroves. We would like to know how you engage or how you relate to these ecosystems within your jobs. Please free to choose more than one option if that is the case. And of course, if you are curious about this topic but currently do not engage in any of these activities, then there's also the last option, which is different and else. For different and else activities. So right now I can already see from the answers as they are coming in that there are quite many of you that are involved in the mapping or the inventory of mangroves and peatlands. And this is a topic that we will hear later on by one of our speakers. And then, of course, there's also quite a few of you involved in developing emission factors for these ecosystems, which is also a topic that one of our presenters will touch upon. This is great. And I think it's also great to see how these different activities are very much represented in the room. So it's really good to know what are the interests of you as a whole. Like I said, I will keep these questions open, but it would be good also in the interest of time to go into the agenda itself. So there are a few presentations that we will have. The first two will be led by Maria Nutinen from FAO and by Crystal Herduas from C4ECRAF. They are both tropical wetlands priority R&D colleagues within the GFOI R&D component. And then these presentations are going to be followed by a presentation by Ake Rosenqvist and Arimatea de Carvalho Ximenez from the Japanese Aerospace Exploration Agency and from C4ECRAF respectively. Afterwards, there will be a panel discussion, and I remind again for all participants to please leave your questions in the Q&A box, which will be monitored by the presenters during this event. And before we get started with the first presentation, I would like to introduce a new GFOI resource that has very recently been released, which is the Blue Carbon Guidance. This GFOI-led guidance aims to support countries in integrating coastal ecosystems. So in this, therefore, it's quite timely that it has been released so close to this event, and we are very happy to be able to share this resource with all of you in this broad space. And it aims to support countries in integrating coastal ecosystems such as mangroves, seagrasses, and salt marshes into their national greenhouse gas inventories. In that way, to strengthen their ability to measure, report, and verify emissions and removals from these carbon sinks. The guidance itself consists of practical recommendations, best practices, technical insights to enhance data collection, as well as remote sensing applications and also considerations for reporting consistency in line with IPCC guidelines, and also in the context of receiving result-based payments. We hope that this guidance module assists countries to measure, report, and verify blue carbon for initiatives for climate action, conservation, and sustainable development, and empowers them to better account for coastal ecosystem contributions in their emission strategies. I see that Madison has already shared in the chat the link where you can access this module. It's available online. You can also find it in the GFOI family of resources or in the QR link in your screens right now. Now, I would like to get started with the first presentation, which is led by Maria Nutinen from FAO. So I will stop sharing my screen, and Maria, you can start sharing your screen, and we can get started with the first presentation.
Thanks a lot, Danielle, and thank you for the wonderful organization. Let me try sharing here so that you see it in a full screen mode. And good to see so many people online today already. Here we go. I'm going to present just quickly about wetland monitoring for climate benefits, for different types of benefits, and thinking about principles, new areas of work, and some recommendations. This is building on our work, especially on peatlands, but also on mangroves, where I've been involved here at FAO since 2011, and the whole big teams on the mangroves and peatland work areas have been contributing to this kind of overview of certain key areas. Let's put it this way, because of the interest of time. First of all, I wanted just to draw your attention. Many may have seen this slide already before, but on why there's such a overwhelming interest at the moment on peatlands and also mangroves, because of their so significant carbon storage. they're kind of a different animals in many ways, with mangroves being very dynamic, fast growing, and fast in capturing carbon, whereas peatlands are like a slower sequestration is ongoing there, but they can stock the carbon for thousands and thousands of years and have developed over that time. But now, of course, in the situation of climate change, we are in the situation where both of these high carbon ecosystems are being both degraded by man, but also impacted by climate change, the differences in water cycles. So these carbon stocks are often threatened. Also, that's why we should be looking at the wetlands also from the adaptation perspective. These are some examples from partners on UNFCCC parties, so countries and regions who have submitted their nationally determined contributions before December last year. There were a lot of emphasis on different types of benefits from wetlands, including, for example, mountain peatlands that are helping to maintain the water balance and keeping water up and slowing it course when it's coming down, but especially when considering coastal wetlands, not only mangroves, but also, for example, seagrasses, their importance for food security, protecting from storms and other types of changes in the climate. So just wanted to draw your attention on that nowadays it would be beneficial to consider also the climate impacts. Just give you one example from the Bahamas, for example, when 2019 a massive hurricane was destroying big part of the country's mangroves and therefore leaving a lot of communities, infrastructure very vulnerable to the climate impacts of stronger storms, waves, and so forth. Why we're looking at the wetland monitoring for climate needs, there are a lot of requirements. Of course, all is building at the moment from the mitigation side on the IPCC wetland supplement, which was released in 2014, and the year is 2013. Both mangroves and peatlands are included there, and also other types of wetlands. However, as you see from that year, it's already over 10 years old, and there has been a lot of new research, new information, and there are now processes to hopefully update it at some time soon. From the adaptation and mitigation perspective, of course, the NAPs are also a way. So NAPs are the adaptation plans, the biennial transparency reports, the BTRs, that we have received now. A lot of countries submitted in December and onwards. A lot of countries are starting to include slowly wetland components there. Of course, the UN Decade on Ecosystem Restoration brings new attention on how the wetland restoration is succeeding. Should we be adapting it? Are we really increasing the carbon storage and so forth? And of course, there are integration with disaster risk reduction, early warning and action. Also, thanks to the new targets and indicators under the global goal on adaptation. If you have questions about this, I'm happy. This is kind of my policy area, is my work, and I have been collaborating to these multidisciplinary teams on peatlands, first of all. So one thing that is often a kind of challenging for many foresters or people who are entering the wetland topic from the forest perspective is like what you actually monitor what you need to monitor when you're monitoring peatlands. So indeed, one important difference to forest area are the peatland inventories, similar to forest maps, but you need to look there very much the degradation status or condition of the peatland. You have to have, for example, soil sampling to be sure that this area is a peatland, and also see if the water has been drained and therefore it is or the peatland is degrading and causing emissions. So that first part, the pillar, and here the triangle in the behind is kind of describing very much how big part of the effort needs to go into the knowing where the peatlands are, the mapping efforts, mapping and assessment efforts, knowing the condition and the degradation status. Then there's the activity data. Um, Indeed, for example, the drainage, is there utilization for cropping, grazing land, forestry, infrastructure? What's happening there? Are the restoration activities ongoing? And then after that, you need the emission factors. And this is, of course, also often a big challenge, especially, let's say, in Africa and other countries where there are not very many studies yet on how much emissions are being emitted by year, by hectare or unit of area. So just to come back a little bit on the importance of the field inventories, this is not something that can be learned from online courses. We would very much recommend organizing a lot more field inventories and training people, like here we've done with US Forest Service in DRC, and doing transects, following the guidance, but learning those basic skills and also analyzing the soil sample in laboratories. That's a very important baseline setting in the countries where the maps are lacking, or there has been a lot of degradation since, and the maps and inventories need to be updated. The second area, and I'm sure that Christel will talk a lot more about these, the refining greenhouse gas emission factors. So different organizations, including ours, together with the UK Centre for Ecology and Hydrology, we are working at the moment with backing out the new studies, looking at different subcategories for forested peatlands, and developing what could there be a kind of a robust way of estimating emissions based on the groundwater level, something that could be, for example, considered when estimating greenhouse gas emissions in greenhouse gas inventories and reporting, and other reporting. Very briefly on this, you have probably questions. Then I wanted to just share on the research and development side. We've been working with Indonesia for a long time, trying to collect groundwater level information, what I just mentioned. And then we were able to correlate it in this peatland hydrological unit with our remotely sensed and modeled groundwater level estimates. So here you see that the groundwater level, which should be around the zero, around the ground, in a healthy peatland, here it's going lower between the seasons and different years and the climate. And this is area where there has been some restoration efforts ongoing. Very, very briefly on mangroves, just wanted to share this FAO inventory on world mangroves, which was conducted in collaboration with many countries with intensive training. And one important result from that was the drivers of mangrove laws. Here you see just a rapid snapshot of different types of drivers, and they differ very much from different regions. So this is also important to understand what is causing the degradation and deforestation of mangroves. Some take-home messages, building on our long teamwork on this, is very important on wetland monitoring to involve wetland scientists and experts in soil organic carbon, on different types of cultivation, drainage, alteration techniques. So otherwise it can go very wrong if we are only looking at the land cover changes, for example. It's important in different countries, of course, to work across sectors and mandates. In mangroves, for example, the marine units and fisheries are very important. Similarly, in the peatlands, I've already mentioned the different land uses, which are causing peatland degradation, but also water extraction companies might be very aware what kind of activities are ongoing there, or they might be interested in water quality And they might be actually draining also water from wetlands. Also, the Ramsar focal points are very important resource in the countries, often lacking quite a lot of resources, but very knowledgeable on where the wetlands are and what's their condition, and also on biodiversity aspects. So one key point, of course, we would like to encourage and all colleagues to contribute to developing new science, for example, to those researchers who are there to update the wetland supplement, and also for many technical agencies to make its content better available and understandable to countries. And finally, I know I'm going over time here, I would recommend everybody to support different countries and organizations in integrating wetlands into the nationally determined contributions, the NDCs, as well as the national adaptation plans. There has been a big push to make these two happen. And so now is a good time to draw attention on wetlands as climate powerhouses and work together for this target. Thanks a lot. And back to you, Daniela.
Thank you, Maria. And I can see a few questions already in the chat. There are no clarification questions in the chat itself, so I suggest that we move on to the next speaker. So up next is Christel Herwalch from C4 ICRAF. Christel, please feel free to share your screen and start your presentation.
Thank you, Daniela. Can you see my presentation?
Yes, we can.
My problem is I don't see it myself. Okay.
It's not yet in presentation. Oh, yes. Now it's in presentation mode and we can see the slide. Yes,
perfect.
It's perfect.
So thank you. Hello, everyone. And thank you for attending this GFOI wetland event. My name is Christel Herwalch. I'm a senior scientist at C4 ICRAF. And I'm very happy to be here to present an overview on peat greenhouse gas emission factors, their concepts, their applicability, and research needs. So peatlands in their natural state are flooded with vegetation organic matter inputs exceeding their decomposition rate. So they are active soil carbon sinks, sequestrating about 1 ton of carbon per hectare per year in in the tropics. They have accumulated large carbon stocks in their soils over millennia, as you can see on this figure, which is based on IPCC defaults. Their soil is a net CO2 sink, a large methane source, a nitrous oxide source. And so their soil act as a greenhouse gas sink or a small source, depending on the ecosystem and the region. You can see here the balance of the 3 greenhouse gases based on a literature review in an undisturbed tropical forest. Degraded peatlands are major greenhouse gas emitters. After land use change, the soil is a net CO2 source, a methane source, and a nitrous oxide source. So it's a net greenhouse gas source. And you can see here a comparison with the undisturbed forest I showed before. We can see the balance of the 3 greenhouse gases in an acacia plantation on peat and a rice field on peat. So the most preoccupying activity are the fires. Fires emit large amounts of greenhouse gases into the atmosphere. And you can see here the IPCC defaults for land clearing fire. How are these peat emission factors measured and computed according to the IPCC guidelines? The peat emission factor for fires is the product of the mass of peat that is burned, a combustion factor, and an emission factor for each greenhouse gas. So the mass of peat that is burned depends on the burn depth and the soil bulk density. And the IPCC makes a distinction between wildfires and prescribed fires. The combustion factor is simply the percentage of mass that is burnt, and the emission factor refers to the mass of greenhouse gas which is produced per mass of peat combusted. For a given land use, we have different emission factors. We have on-site emission factors for the three gases and off-site CO2 emission factor. The off-site peat CO2 emission factor refers to dissolved and/or particulate organic carbon which is exported from drained soils. And the on-site peat methane and nitrous oxide emission factors refer to the emissions or the uptakes of these gases from the soil, but also from drainage ditches. The on-site CO2 emission factor is a key factor in the balance of greenhouse gases in peatlands. It's computed as the balance of carbon that enters through the soil from litterfall and root mortality, and the carbon that goes out outside of the pit from heterotrophic soil respiration. So cautious here, heterotrophic soil respiration equals total soil respiration minus root respiration, and peat CO2 loss doesn't equal soil respiration. It doesn't either equal heterotrophic soil respiration. I'm providing here an example of peat CO2 emission factors in tropical settings. On the left side, you can see an undisturbed forest. So I have used some defaults from the literature reviews. You can see the on-site peat CO2 emission factor and the off-site peat CO2 emission factor, both of which lead to an uptake of minus 2.5 tons of carbon per hectare over 25 years. So I'm using 25 years because I'm comparing to an oil palm plantation, which rotation time is typically 25 years. You can see how these emission factors, the on-site and off-site emission factors, increase with land use change. And in that specific case, we can also include a fire since land clearing is typically practiced before planting oil palm on pits. So with this data, we can conclude that the conversion of forest to oil palm plantation leads to a loss of about 300 tons of CO2C per hectare over 25 years. And this is only from the soil. So to conclude this talk, I wanted to highlight that the IPCC defaults for the tropics are based on data almost exclusively from Indonesia. And so that the estimates and the land classes may not be representative of American or African countries. There are important class gaps in the tropics, but also elsewhere. So as Maria mentioned before, one of the gaps are mountain peatlands, and the other is undrained degraded peatlands. The IPCC encourages the development and the use of Tier 2 and Tier 3 emission factors. And so I wanted to present you this study of process-based modeling of greenhouse gases in oil palm plantations. So you can see that in this figure, we have the modeling of peat CO2 and nitrous oxide emissions. We have the orange curve for CO2 and the other two curves for nitrous oxide. So one is nitrous oxide from decomposition of the peat, and the other is from nitrogen application. Over time, these emission factors change. They either decrease or increase. And so this kind of exercise is useful for deriving, for instance, decadal averages that can be used to report more accurately the emissions in this kind of ecosystems. That's all I wanted to share with you, and I thank you for your attention. Over to you, Daniela.
Thank you, Christelle. And I do have some questions, but they are not clarifying questions, so I guess I can save it for later. But thanks for providing an overview, and I think it also ties very nicely with with Maria's presentation, and also towards the end, and the need to interact with researchers that are actively doing some work in wetlands in the fields of interest. But I would like to move on and go from peatlands to mangroves. So I am going to call on Ake Rosekvist, who will present on mangroves, mangrove mapping, and other things. Okay, please feel free to share your screen.
Great, thank you, Daniela. Thank you very much, Dan. So my name is Åke Rosenqvist, and I represent the Japanese Space Agency, JAXA, and the Global Mangrove Watch Consortium with my colleagues Pete Bunting, Lambert Hilarides, and Takeo Tadano. So I'll focus on the Global Mangrove Watch dataset and the Global Mangrove Watch platform, and just to provide a little background to what that is and its potential relevance to activity data and emission factors for mangroves. So the Global Mangrove Watch platform, it's a web platform, www.globalmangrovewatch.org. And on this platform, we have a number of different mangrove data sets. We have a data set on mangrove area or mangrove extent. We have a data set on annual changes in the mangrove extent. We have a data set on early warning, data set on species, and on blue carbon. So I'll talk a little bit about these ones, except the species ones. So first of all, just to give you a little bit of background, so the Global Mangrove Watch extent map data set, it's derived from a combination of radar and optical satellite data. So the reason why we're using both optical and synthetic aperture radar is that they have different capabilities that are both kind of useful for mangrove mapping. So basically, the first thing we do is to map the mangroves using optical satellite data, because optical satellite data, they're sensitive to the vegetation spectral characteristics. So that will help us to distinguish mangrove from non-mangrove species, which still can be a bit of a challenge, especially on the land side of the mangroves, where you have other types of wetland vegetation, salt marshes, etc., could sometimes be difficult to distinguish from mangroves. However, also the optical data is limited by cloud cover. So that's why we're also using SAR data, synthetic aperture radar data, because with SAR data, SAR satellites, we can acquire data regardless of clouds or smoke or haze. And we are using what we call the L-band radar. So that's kind of a long wavelength band radar that is sensitive to vegetation structure, and it's very good for detecting changes if you have a time series of data. So the optical data we have used to develop what we call the baselines, and we have two baselines, 2010 and 2020, where we have been using Landsat and Sentinel-2 data. And then we have a suite of Japanese JERIS-1, ALOS-1, and ALOS-2 satellites that we have been using to detect changes on an annual basis between 1992 and 2023. So that's kind of the basic kind of what the data set is. Let's see if I can. I seem to have frozen here. This okay. So we have currently in 2022 we released what we call the version 3 of the Global Mangrove Watch dataset. That was a time series data between 1996 and 2020. and that is currently what is used. We are planning within the next few months to release what we call the version 4. It will be released on the World Mangrove Day in July. And there we have extended the time series. So we're actually going back to 1990 using Landsat data. And we're going all the way to 2024. And we will continue to add on data every year. So for that one, we have 15 annual epochs from radar, and we're having 8 annual epochs from optical data. The thing with the extent map here and the changes that we can detect is that is basically activity data, you could say. So basically mapping of the anthropogenic changes, that's activity data. You have an example here. For instance, with version 4, we will be able to separate. We will have a separate data layer for losses per year and a separate data layer for gains. So losses could be, for instance, land conversion or timber extraction. Gains could be restoration projects. What you see here is an area in Sulawesi where you have land conversion. So this green mangrove area is then converted into primarily rice production here. So that's kind of basically you will have area estimates of the changes per year. We're also mapping non-anthropogenic changes. So that could be losses due to erosion or dieback, storm damage. But also we're mapping gains. So for instance, on the left side, you have an example from the Orinoco Delta, where you have sedimentation coming from the river sediments, where you have mangroves colonizing. On the right side, you have is the Sundaban wetlands, where you have erosion of the mangroves, also due to kind of natural causes. So basically, what we can produce are both regional and country level statistics on an annual basis, and this could feed in to help with activity data for your countries. What we're also having is a mangrove blue carbon layer. So basically providing proxies for emission factors, because we know that the IPCC default emission factors are not developed for mangroves. So this could give you a first cut on the emission factors. And this data set here consists of one data set on the above ground biomass. So basically we have mangrove heights and mangrove above ground biomass estimates, and also another data set on the forest, the mangrove soil carbon. Also, we're having a data set or an activity that we call the Global Mangrove Watch change alerts. So basically, it's a mangrove early warning system where we use optical Sentinel-2 data on a monthly basis, where we indicate areas that are likely to be subject to change. And this is an operational service that we provide on the Global Mangrove Watch platform. And we are looking at, say, ways to reduce the false positives, the false classifications. Currently, the Global Mangrove Watch change alerts, they cover about a third of the global mangrove areas. And we are working to expand this to cover all mangrove countries in the first half of next year. All these data, they are public open access data. and they are provided under what we call the Creative Commons CC BY 4.0 license, which basically mean that you are allowed to use these data sets the way that you wish, as long as you recognize the origin of these data and attribute those to the Global Mangrove Watch. You can find raster data at the JAXA website, where you can download the entire kind of archive of Global Mangrove Watch data in GeoTIFF format. On the UNEP Ocean Data Viewer and on Zenodo, you can download the vector data, the shapefile data. It's all free of charge. And just the last slide, just to mention that there are a number of web resources that are already used in the Global Mangrove Watch data set. The most prominent one, perhaps, is the UNEP SDG 661 app. So basically, UNEP are using the Global Mangrove Watch as the default layer for countries that are lacking their own natural mangrove monitoring systems for reporting on the SDG indicator 661, which is change in the extent of water-related ecosystems over time. Also, the World Resources Institute, the Global Forest Watch, if you switch on the mangrove layer there, it's actually the Global Mangrove Watch layer, and the same thing for their Resource Watch website. UNEP WCMC, their Ocean and Habitat website, is also using the Global Mangrove Watch website. So basically, that's the end of my presentation. And just to say that the Global Mangrove Watch data set, it's basically, I would say, for countries who don't have their own mangrove monitoring systems. And it's a good starting point if you don't have anything else to start with. Of course, countries that have their own monitoring systems, this is a global data set. And as a global data set, one has to realize that when you zoom in at a very local scale, it might not be as accurate as your local maps, where you have all the kind of potential ground data available. But it's a good starting point, and please use it as much as possible. Thank you.
Thanks again. Thanks for the presentation. It's great to see all of the advances in global mangrove monitoring, and also thanks for the clarification as well. It's good to know that indeed this is a great resource, but of course for regional efforts might need would probably usually and likely need additional steps in developing regional products, as well as, or perhaps working into calibrating and so on. It's good to mention this as well. I would like to also see, let me just check if there are any clarifying questions. There are none that I can see in the chat. So I would call for Ari to please share your screen. This is the last presentation that we have today before we go to the discussion session. And also a small reminder that this event will be, the recording will be shared online in the coming days, as well as the presentation materials. So Ari, you can please.
That was okay.
Yes, it's perfect.
Oh, great. So, hi everyone. Thank you for having me in this meeting. I'm going to present my work in comparison of global mangrove maps for future distributions. It's a publication that we did in 2024, and we want to compare different maps, mainly focus on the range limits of mangroves, because we see that most of the maps, they have some differences between the range limits, and also some publications that they use some global maps, they make the wrong exactly position of the range limits. So the results also will be different for future scenarios. And we use as a basis this work in 2012 from Catherine, and she did a temperature variation among latitudinal range limits. And this work, she was very focused on the range limits, so she talked with a lot of experts in each country, so she has a more precise position of the range limits. So we use this work as a basis, the positions. And the objective, as I told you before, is to compare different maps, focus on range limits, to investigate the differences, and also to recommend some future recommendation for future mappings. So we compare 4 global maps. One is the World Atlas of Mangroves 1 from Spalding 97, and also World Atlas of Mangroves 2, that was an improved version, and also the Global Distribution of Mangroves from GIRI, and after the Global Mangrove Watch, as was presented before. Very nice presentation. So here we show a little bit the difference between each range limits from different global maps, that you can see that they have a slightly differences from the limits. And here we show the latitudinal limits that we can compare. The second, the B, we see the difference between the maps and the Catherine's works. So we see that there are a big difference in different maps. And another one, the figure C, is the maximum latitudinal difference with all maps. So they have a big difference in mainly these 3 places: Baja California, in North and West Africa, Japan, and West Australia. They have a huge difference between the maps. And we also we extract from each range limits from each map the value of the minimum temperature from World Clean is a BO6, the temperature of the coldest month. So we see the big difference in Japan and also West South America. So we see Iran as well. And all maps, they have a different values for temperature. So when we also use the future scenarios, will be a big difference if you use different maps. Here for annual precipitation, we try to use all the variables that we know that there is an influence on the range limits of mangroves. It's mostly regarding the minimal temperature, also precipitation, and also the precipitation of the driest month, that they are the variables that they have the most influential on species distribution of mangroves. And here we see that different variables, they have a more differences in all maps. You see, before was West Baja California, and here in this precipitation of driest months, they have no difference, because in different latitudes, they don't have a variation. But like in China or Taiwan, Japan, and West Australia, they have a huge variation. And also this variation is translated here that they have a big changes. Here, just for one example, in Brazil, we see that most of maps, they put the range limits very close to Florianópolis. That's about 27 latitudinal degrees, but the range limits is very low, below in the south, in 28 degrees and 30 seconds. And also the only map that could, the global maps, if we compare all the global maps, only map that could found the position of the range limits in Brazil was the Spalding 97, but even that they put the wrong position, that's a bit more in the left side. So they found the range limits, but a bit different position. But even in this position, when we use the global climates, doesn't have a big difference. The importance that they have the same latitudinal limits. So the results, there is a huge difference between the global maps regarding the range limits. And these small discrepancies between maps, particularly in areas with difficult terrain and also in remote regions. And the Global Mangrove Watch offers the most especially complete and up-to-date coverage, because they integrate the SAR and optical data. So in global scale, we didn't make this analysis on global scale, looking all the places, but we know that they have the most complete spatial distribution of mangroves. But even this map, they have some issues regarding the range limits. So the idea is to make this paper was to alert the global maps for futures updates. They also include these range limits. That's very important. And sometimes the classification, the automatic classification, they don't get these range limits, because usually they are very small mangroves areas. So when they do the classification with 30 meters resolution, sometimes they don't get the mangrove. So they should also include the local expert validations in their maps. Most of maps, they do that, but also focus on the range limits. That's very important for future scenarios. So the importance of to map the global the range limits is for conservation and also for climate change mitigations policies, and support carbon stock assessments. And for future directions is to refine the mapping techniques and also to enhance the climate impact projections. So thank you for your time, and here's my contact. So that's it. Thank you.
Many thanks, Ari, for your presentation. And also yes, indeed, for seeing, for providing such an interesting approach to compare different global biomass products with regards to future changes as with the warming climate. I see in the chat that there are also people also sharing additional guidance or additional resources related to blue carbon and tropical wetlands monitoring and reporting initiatives. And I would like to encourage the rest of the audience that if you have anything that you would like to share with all other participants, to do so in the chat. This is very much encouraged, and also very much the purpose of having these sorts of events. Now that all presentations have also happened, I think we can also move to the discussion session. So I would like to have all of the presenters today to turn on their camera and their microphones. I see already that there are quite a few questions in the Q&A chat, which is great. And if I see that there is one question specifically related to Ake, related to his presentation on the Global Mangrove Watch. It's by Antje Ude. It says, can you see it, Ake? It says,
Yep,
how do you...
I can see it. I can respond.
Perfect.
Yeah, right away. There are a couple of questions in here. I mean, first, how do you confirm the drivers of change? First of all, the Global Mangrove Watch data set does not say include the drivers of change. That's something, I mean, we cannot say see the driver of change or detect it automatically. Visually, I mean, certain drivers of change, like the ones that I showed, it's quite obvious what is the driver. I mean, if it's sedimentation or erosion, land conversion, but it's not always completely clear what the driver is, and sometimes you have several drivers interacting. So in the Global Mangrove Watch, we actually do not have, we do not kind of separate what the drivers are, but there are a number of papers where they have been looking at that and try to use other indicators to look at drivers. And I think I can dig out some references for you, Ante, where you can have a look at that. Then your second question was how tide plays in the change detection, and the simple answer is that it doesn't. The tide with the radar data, interestingly enough, normally with an L-band SAR, long wavelength band SAR, you can actually see through the canopy and you can see the water below the canopy. However, that is not valid for mangroves. That is only valid for forest types that have straight trunks. But the kind of crooked types and the kind of complex root systems kind of absorb the signal, and this kind of specular double bound signal that is kind of characteristic for that is absent. So we actually don't see any change of the radar signal kind of regardless of the tide, which is kind of both good and bad, I suppose. So that is not a problem. I also see that there is another kind of, while I'm at it here, there is one more question from Henry Terunga Kashima. How do you detect or do the change detection analysis in the mangroves? Basically, what we have is that we use the optical data to create what we call a base map. And that is basically a mask image that tells us where we can expect to find mangroves. And then we use the radar data to look at the time series of radar data, and then we look under that mask. And in areas where we have big changes in the radar reflectivity or the radar backscatter, we will know whether an area has changed from non-mangrove to mangrove or from mangrove to non-mangrove. So that is kind of the strength of the radar data, but it kind of requires that we have a good mangrove mask to start with, and that's what we're using the optical data for.
Thank you. I would like to shift to peatlands now, and I see that there's a question by Ximena Herrera on peatlands themselves. So to the question for the speakers on peatlands, so Maria and Christelle, what would be a cost-efficient or simple method to monitor changes and degradation in peatlands?
Thanks for the question. But what do you mean what do you want to monitor exactly? Is it the land cover that you want to monitor? Is it the greenhouse gases that you want to monitor? There are different methods, but the first thing is that you need a peat map, and that's the main point, because many countries in the tropics don't have any peat map, so you have to rely on global products. Monitoring degradation. Okay, so the question is monitoring greenhouse gases. So that's even more tricky because first you need to get an understanding of the kind of changes that are ongoing, whether you have forest degradation, whether you have land use change, deforestation, etc. And then you need to get a sense of this greenhouse gases emission. So, for instance, if you don't have any drainage, you may have not so much changes, for instance, in methane fluxes and nitrous oxide fluxes, except if you have nitrogen application, but you may see changes in CO2. So you will see changes in CO2 from the vegetation, but also from the peat. And for this, you need to use the emission factors. Basically, if you have drainage, then there's going to be big changes not only in CO2 but also in the other gases especially for methane, you will see a decrease in methane emissions. And so, unfortunately, to date, there are no so very good proxies that allows to do the remote sensing from to monitor from remote sense products. Like, for instance, there were questions about the water table. Eventually, methane has a good correlation with the water table, but for the other gases, it's still a challenge. I don't know, Maria, if you want to complete.
No, I think we were discussing here with Matt that Crystal can handle this, no problem. And I had also that pyramid in my presentation, if that's helpful. But indeed, the wetland supplement is probably the best guidance indeed. It's a bit tricky to read and understand, but that's kind of the way to calculate it. For Indonesia, we did create this tool called peat GHG tool. Maybe we could put the link in the chat with Laura and Matt. It was tailored for Indonesia for rapid calculations of greenhouse gases from project area. Let me just very briefly, I put it in the chat to respond your that could be adapted also to other country contexts, and you can change the emission factors if you have better ones or more, higher tier level emission factors. You can add them in the tool. So that Trello links as kind of an overview of different types of tools and guidance, and including there the peat GHG calculator, and that's for Indonesia indeed. Thanks.
Maria, so then this will be shared in the chat if I'm correctly understanding it, right? That's perfect. And indeed, I would really like to encourage the chat to be a place in which people can share any experiences beyond the presenters in this group, anything that you might think would be of use to other teams and other people that are working on monitoring these ecosystems. It would be of great use to also share it widely in the chat. Let me check. Let me check the questions that we have in the Q&A. If anybody wants to ask a question via using a microphone, feel free to raise your hand. I see that we have a question by Mauricio Solis Campos about accessing methodologies for delimiting estuary wetland ecosystems applied in other nations and regions. In that way, that's also why I think that the chat option is a useful resource. This exchange and also all of the presentations will be made available after the webinar. But of course, if there's any targeted resource that anybody from the presenter team would like to also offer, just feel free to speak up. Following this, there's also a question by Naomi, and I think, please, Naomi, correct me if I'm wrong, the question relates more to how can we highlight the importance of conserving peatlands and these types of ecosystems in general. And I think this is also a question, maybe Maria, that you can take over.
Yeah, with pleasure. Thanks a lot. So, Naomi, indeed, you were asking about, for example, destruction through replanting of forest, which is not native to peatlands, I understand. And this happens especially, for example, in some parts of northern Europe, where the conifers are planted on peatlands, and even without drainage, the conifers are causing so much evapotranspiration that the peatlands is actually degrading. So that's one way of degrading peatlands, but there are plenty. For example, cropping is one of the most broadly used in different regions as well, and because of the fertilization and so forth, it causes very intense emissions. I see one interesting thing, maybe you've seen it on social media, where they were highlighting how beavers were restoring peatlands, and that has been made it to the main news, for example, in France and so forth. That's an interesting way of communicating how ecosystem can sometimes restore itself. In this case, with the help of beavers, raising back the water tables to the natural state. But indeed, I think there's a lot to do on this, and the Global Peatlands Initiative and other partners been working quite a lot to raise more awareness and indeed emphasize the need also in the countries to develop the capacity to monitor peatlands and report on their emissions. Thanks. Back to you, Daniela.
Thank you, Maria. I have, let me just check if there are any, I do not see any questions that we have not answered in the Q&A box. But I do see that Ake has raised his hand. Ake, please go ahead. You're muted right now.
Yeah, right. No, just to fill in, there was a question on drivers on change, and actually, my old colleague Adam Durand was kind enough to point me to a report from the FAO on drivers. I also found 2 other papers that I put in the chat that also deals with drivers of mangrove change that you can have a look at.
Thank you. And indeed, it looks like the chat is very lively, and it's a bit difficult for me to follow the Q&A box as well as the chat itself. But it's great. It's great to see the wealth of knowledge that is already being shared. I think yes. Okay. If there are any more, Maria, could you please?
Yeah, this is then one work area where FAO hasn't been developing so much our capacity, but just wanted to draw your attention on a wonderful scientist in the TNC, and this is about mangrove monitoring. Let me just share very briefly on the screen again. These remote sensing techniques for mapping and monitoring mangroves at fine scales. This is especially using drones and that can pick up also kind of very small dwarf mangroves and very small changes, and can be also developed capacity at the national level with the drones and repeated flights, for example, for collecting quite interesting information, for example, of restoration sites. That's something that could be useful for some of the partners. I put it also in the chat. Thanks.
May I just make a comment on that as well? I think that's a very good point. And just to say that, say, drone mapping and this kind of fine scale mapping is very complementary to what we're doing with the Global Mangrove Watch. One of the limitations of the Global Mangrove Watch data set is, of course, the spatial resolution. We have a pixel spacing of 25 meters, and it means that very small mangroves, kind of along kind of smaller rivers, kind of mangroves in, say, in Pacific Island countries. They may not be kind of very large, but they are very important for those countries. And that's kind of a challenge for us to map at the spatial resolution that we're having of our data set. In the new version 4.0, the new base map that we have generated is actually generated from Sentinel-2 10-meter data. So if you go to Zenodo, you can actually find the 2020 baseline for version 4 already. That's at 10 meters. So that's slightly better. But of course, countries who are doing kind of their own mapping, where you actually go out in the field with drones and so on, of course, you can improve the quality drastically. But as I said, the Global Mangrove Watch data set, I think it's a good starting point, especially for countries who don't have their own mapping systems. And at least it will give you a starting point to know where to look for your mangroves. And then you can work to improve the map.
Thanks, Ake. I see that there's a few questions in the chat. And one relates to peatland revetting. So Yayani is asking, Cristel, maybe you can answer how much peatland revetting can assist in carbon stock conservation. And then there is also a second question related to peatland maps and how they can react, how if there is any guidance, recommendation, or analysis by FAO. Perhaps this is more of like a specific question that Maria, you can answer in the chat, but is there maybe Cristel, you can answer the first question?
Yes, thank you. Thank you, Daniela, and thanks for the question. So rewetting is important. You bring back basically the ecosystem in its natural state. However, it takes time for this system to go back to its biochemical cycling. And it's not only about rewetting, you also need to bring back, replant, and if possible, the natural vegetation. But it may take 50 years or 100 years for the soil to come back and sequester carbon stock and accumulate carbon again. So it's good. It's good to restore. It's good to rewet so that you stop the high emissions that come from drained peatlands. But we must keep in mind that it's not because you rewet that one day, one year or 10 years after, you are going to significantly reduce the emissions. It takes a lot of time. Thank you.
Thank you. Thank you, Cristel. I see indeed then this has been answered. I actually have a question for Ari Matea. And Ari, I was really interested to see in your presentation. I think it was an interesting outlook of how when it's being when global mangrove maps are being compared, it is important to adequately use reliable validation data. And this also ties with the comment that Ake was mentioning before. What would you consider are the critical aspects for validation data, regional validation data, to be considered adequate for this purpose?
The validation data. I think in the case of range limits, we already have the points, the positions. So I believe that we have to focus on that places to map and also validate with experts for each country, mainly because some places if you talk with the people from the local places, they know exactly where they are, or even the literature. For Brazil, we have a lot of papers telling that the limits are in 28.3 degrees. So is well known a long time ago. So, but the map is, I think, because the area is too small that they cannot mapping or. So I think we have the location, so it's easy would be easy to really to map these areas.
Perfect,
Not
thank
easy,
you.
but at least could be also it's possible to map these areas.
Thanks. Ake, I see your hand is raised.
Yeah, just to respond to Ari. Yeah, in the Global Mangrove Watch, basically we have what we call a habitat mask that we use to initially where to look for mangroves. I mean, we are not looking kind of across the entire globe for mangroves. We are looking where mangroves can be expected to exist. And your kind of very southern mangrove area in Brazil, it's very likely that it was not included in our habitat mask. And that means that we're not mapping it, even if we could see it. So if you, I mean, we are kind of consistently collecting information from users who, because clearly, I mean, our map is not 100%. There are many mangrove areas that we have missed because we don't know kind of where to look. So, I mean, just to you and to others kind of on this seminar, if there are kind of mangroves that you know exist, send us a shapefile and we will include it in the mapping of the next version of the Global Mangrove Watch. It's a continuous kind of activity that we're doing.
Great.
Thanks.
Thanks.
Thanks. Yes. Thanks again. It's great to see. I think we are relatively on schedule, but I wouldn't want to be overly optimistic. So I would like to close this Q&A session, unless of course there's maybe a last question. I do not see it in the Q&A box. And I would like to offer the floor to Christelle or Maria as GFOI R&D Tropical Wetland co-leads. If you have any final thoughts or I don't know, questions that you would also like to pose the audience, please go ahead.
Yes, it's really nice to see so many people connected and interested in the topic of wetlands, of peatlands and mangroves. We critically lack data, ground data, to be able to use these remote sensed products and validate them and make some global estimates and valorize these peatlands so they are not destroyed, as was mentioned in the chat. So please go to the field and do some sampling. Maria?
Thanks a lot, Christelle and Daniela. Yes, it's been a really interesting process to organize this session and see the multitude of what different organizations are doing on the topic. I would like to highlight also that there are a lot of organizations starting to work on salt marshes, and I hear that seagrasses salt marshes and seagrasses both are receiving a lot of attention and are important also for the global carbon budget. So let's not forget about those, even though they are not forested. And I wanted to also invite indeed all collaborators. Also, if you're interested in this, get in touch also with the Mangrove Breakthrough people. If you're in country, maybe through the NDC partnership, and let's work for those climate commitments as well. But I agree with Christelle, the ground data is the big gap that we have. Thank you so much.
Thanks, Maria. Thanks, Christelle. I think then we are through the agenda, so I will just close this session. First of all, I would like to thank all of the presenters for lending their time and also their expertise for today's session. Also to Madison and Ellie, who have been working and helping us out in the background of this event. And also to all participants for your questions. And I hope that they have been answered in a good enough manner. But of course, feel free, if you have any outstanding questions and so on, please feel free to get in touch with us. So the GFOI R&D exchanges are still relatively new. They're a series of regular events designed to foster these types of discussions. The R&D exchange that we had last time was on near real-time deforestation alerts. And there was also a MGD model on the best practices of how to use and how to develop these alerts. If you would like to hear more about that exchange, it's also recorded and it's also in the main GFOI website. There is a event summary for it as well. So we hope to see you again in future exchanges. Just to recap, the priorities that we are seeing are degradation, and other priorities that we will see in the future are degradation and regrowth mapping, biomass emission and emission factor estimation in forest environments, uncertainty analysis, and land use and greenhouse gas inventories. So please stay tuned for any upcoming R&D exchanges. And if you have any questions or ideas related to topics regarding future exchanges, also please feel to reach out. That is, and with that, I leave you and I wish you all a very pleasant morning, afternoon, evening, and so on.
Thank you. Bye-bye.
Thank you.